Welcome back to Casual Retro Gamer. This week we're going to take a look at our other spare C64 board. This is the one that we borrowed a few chips off last time. We're going to fit some sockets where we took those chips off, and then we're going to try and get this board booted up. Let's get started. So we need to fit new sockets at our character ROM, our SID chip, and our color RAM. I was able to get these nice turn pin sockets from CPC Farnell here in the UK. Let's get them on. Start with a big one here at the SID chip. So just to help hold that in place, what I like to do, get a wee bit of our PVC tape. Just stick that across the socket like that. That'll help hold it down while we flip the board over to secure this in place. And you just want to hold the heat on the leg just for a second, because these are dual sided boards, just to let that solder flow right through to the other side. Before we go any further then, we'll just flip the board over again, take that tape off, and just inspect that our socket is sitting nice and flat. That's pretty good. So let's go ahead and get the rest of the pins secured in place. That's that one done. I'll do the other two, then we'll be back. To try and repair the damage up here around the PLA. That's our 3 new sockets in place. I've given the board a quick clean on the underside. It's quite badly scratched around some areas, but it should work okay. Next thing we have to do though is tackle this pin where the pad has been completely ripped off. See if I can zoom you in to show you this a bit clearer. So this pin here on the PLA, as you can see, it's just completely floating. There's absolutely nothing left of the pad or the through hole there through the board. It's just completely gone. So that is pin 1, 2, 3, 4, 5 on the PLA. And if we take a quick look at the schematics, we can see that pin 5 goes out here. What's that? VA14. So let's see if we can follow that. Goes out here. We'll have to go to the other side of the schematic. Can we find VA14? Here it is here. And that goes through to pin 2 on the second CAA. So that's the underside of the second CAA there. There is pin 2. We're on continuity here. And obviously, as you would expect, nothing happens when we go near that pin. This pad here though is connected. So that's connected through the board there, or supposed to be connected through the board there. Then there's a trace coming across to here, connect on at that point. So all we need to do is run a wee bridge between this point here and this pin, and that should solve the problem. So what I think I'll do is just take a little resistor like this, and we should have a bit of space there that we can get that resistor in down beside that leg, and then we'll flow a lot of solder into there, and then we'll just bend it across like that and connect it off at that point, and that should be it. Right, that's that in place. Let's just test it then on this side of the board for continuity. So from pin 2 of U2 across to pin 5 on the PLA. Yep, we're getting good connection there. So hopefully that is fixed. I don't see any other damage on the bottom of this board other than a few scratches and things, as I said. So I think what we'll do, in fact, look at the state of some of the solder work on this. I'm just going to go around and tidy up some of the existing solder work on this, and then what we'll do is put some power through this board first of all, just to check we're getting voltages as we would expect. Then we'll fire some chips in and let's see what it's doing on the screen. So we're hooked up to the power now. Let's switch the board on. Let's take a look at our 2 voltage regulators first. So on the 7805, just lead out of the way. On the 7805 we have a pretty bang on 5 volts, and on the 7812 11.8, that's fine. How about out around the board? Have we got our 5 volts? 4.88, 4.9, that's fine, yeah, that's okay. Up here, yep. Try our sockets. Yeah, so that is looking not too bad. This is the board, if you remember I said in part 1 of the last video series that the RAM chips get incredibly hot. Wow. Those ones aren't as bad, but that chip there is absolutely screaming hot. I can hardly touch that. Just for a bit of context actually as to how warm the RAM chips are getting on the other board, I pulled this board here out, or this machine out here quickly just to show you on the heat gun. So this has been sitting idle here for 5 minutes maybe, and our RAM chips on this are sitting at around 25 degrees. Some of them there are 26, 28 there for some of them. But all well below 30 degrees anyway. Just in case you're interested, that's why the SID chip needs cooling. Sitting idle, 54 degrees. Yeah, need to get a heatsink on this one. Now compare those temperatures to what is reading on this board. I don't even have to touch the chips. I can feel the heat emanating off them. This has been sitting like this for 5 minutes with the power through it. Over 50 degrees on the RAM chips. 53 there and rising. So yeah, I think something is definitely fried. Now, one thing I'm not 100% sure of with the various other chips missing is that maybe sending the data bus a bit crazy, which is causing these chips to get so incredibly hot. I don't think so, but then again, I'm not 100% sure. Let's put our bits and pieces in here. As I said, we need to put the color RAM in, we need to put the PLA in, and we'll put the character ROM in. And we'll hook up the dead test to see if it gives us any idea of what is going on down here. We have the color RAM fitted, the character ROM and the PLA. Our dead test card is in. Let's see what happens. So we're getting a single flash on the dead test. Let's turn that off again. And then if we take a look at the manual for it, one flash code is U12 on this board. U12 is this RAM chip here. So what I think we will do is we will pull this chip out. We'll put a socket in its place. What we'll actually do is take our other good board, we'll remove one of the RAM chips on that and fit a socket so that we can test this chip in the other board, and equally we can test the new RAM chip in position of this in its socket. So as you can see, I have been busy. I wound up just taking all the RAM chips out. This is them up here, and if you notice, they're all upside down bar one, and that's because 1, 2, 3, 4, 5, 6, 7 of these chips are dead. Only that one is good. That was the first chip we removed. I tried it in the other board. It gave the same problem in that board. Wouldn't boot, black screen. And the dead test pointed that it was faulty. But even when I put a new RAM chip in here and tried our dead test again, I got the same single flash. So very possible that this chip here is also fried, or this one, as these control the RAM to the address bus. Considering that one was damaged and considering all the rest were running so hot, I decided I'm just going to remove them all. Easier to do that, then we can test the RAM and we know they're good. So that's one of the original ones, in fact the only original one that isn't fried, that belongs in there. And I've had to go and order quite a few more RAM chips to populate the rest of this. I originally only ordered 2 because I thought, well, there'll only be 1 or 2 dead. Didn't think there'd be 7. Isn't it just as well? They are quite cheap. Right. Possibly these chips are fried. In fact, considering the damage, possibly these chips are fried. I hope not, because I don't have replacements for many of these. I think I have one of these spare. What I want to do though is we will hook up the dead test again and see with our new RAM if we're getting anything different. Our power's hooked up and our AV's hooked up. Dead test is in. Let's see what happens. I do not have high hopes. Hey, check it out. We're getting some action. Okay, so everything is looking good. It obviously can't do the sound test because we do not have a SID chip in the board. Next thing to do then will be to stick in the missing CIA. We'll have to borrow a SID chip out of one of my other machines. I don't have any more spare. They're kind of expensive and kind of hard to come by. Maybe I'll get myself one of those modern replacements though at some point in the future. But for now, we'll borrow one out of another machine, get that CIA in, hook up a keyboard and see if this thing will boot to BASIC. And then we'll hook up the full diagnostic kit and run a full test on this board just to make sure that everything is working as it should. So we've got a SID in here that I've just borrowed out of one of my other machines. I fitted a spare CIA chip that I had, hooked up this keyboard, and let's see if it will boot into BASIC. So there we are, that's looking pretty good. 64K RAM system, and importantly 38911 basic bytes free. That is the exact amount we would be expecting to see. Is the keyboard going to work? Let's just do the famous hello world. Looking good. Right, let's get the full diagnostic harness out, hook it up to this board, and let's just be 100% sure that everything is working right. Our diagnostic harness is all hooked up, so let's see what happens. Well, there we are. Looks pretty good to me. And we have another working C64 board. The only other things I would like to do to this at some point would possibly be to replace these white sockets, because that's just annoying me. Why are they white? They should be black. This socket here is just slightly too long. Unfortunately, I had to use practically all the sockets I had of that size for the RAM chips, so I suppose I could always solder a couple of these direct onto the board and then recover some of those. Now, can't be bothered with any of that. I'll just order another couple of sockets. They're only pence each. Swap them out. I do have to try and source another SID. As I said earlier, they're incredibly hard to come by. That's the only thing this board will be missing. I might have another look at the ARM SID, or the, what is it called, the Swin SID, I think, replacements. Those can be picked up quite cheap, and it's a modern replacement, so it should last a lot longer than this old chip. Well, that's it for this time. Thanks very much for watching. Hopefully you enjoyed this little board repair, and I'll see you again soon.